Hello all. Thank you for taking time for coming out over here. It's a pleasure to host these stalwarts over here on the stage. Each one comes over here with a different background, but there's some commonalities across all. So first I would like to do a quick round of introductions of each of the people over here on the stage. So I'll start with Kaushik. Kaushik, I met him first at Art Park, but he has an illustrious background. So he's a PhD in mechanical engineering from Johns Hopkins, and subsequently he was a postdoctoral fellow at the US Naval Research Laboratory in Washington, before he came down to India to set up the Art Park. So he was one of the instrumental members of setting up Art Park in IISc, and even now he is a faculty member at IISc. That actually helped him in, I think, crystallizing his thoughts on building Twara Robotics, which is a very interesting concept because across my few years at Intel and earlier as well, I've not seen too many startups which are coming up over here and saying that I want to build for the India ecosystem. So we'll hear more about him saying that what's he doing in robotics from an India ecosystem point of view. The person sitting next to him is Nikhil. Nikhil is another person whom I met ages back. I think in 2018 is when I first met him. And the thing which I saw first was him sitting in a single room in Nasscom IoT in Domblur, the COE over there. And he had that robotic arm over there. And from there, he's grown up into, I'll talk about that later. But so Nikhil, again, is a BE honors from BITS Pilani. He comes with domain knowledge. So he used to be in National Instruments, and he was a principal engineer over there, basically looking at key accounts. So GE, Honeywell, Bosch, over all his accounts over there. And that's where I think he found the gap which he was trying to solve. So like we always say, there has to be a product market fit, and you need to have a real identifiable problem. So while looking at that and while researching across different other companies, he spotted the product market fit, which actually led to the formation of this entity called CynLr. I'm going to do a quiz later on, and no using Google or ChatGPT. What does CynLr stand for? Okay, so let's see how many of you actually know that. So CynLr got founded in 2019, and that's one company which is very unique. I mean, I don't know how many of you remember the ecosystem of VCs at that point in time, but in that framework, he was one of the only, I would say, at least I had not come across anyone else, so he was one of the only companies which got funding pre-product. He did not have a product per se, but he got seed funded for that. So that's basically Nikhil. The last one over here is the veteran out of all of us. He is what I call the Bhishma Pitama of robotics in India. So he's basically Sangeet Kumar. He is the CEO and founder of Addverb. Now, comes from a very diverse background. So comes from Sainik School in Jharkhand, followed by a BTech in chemical engineering from IIT Kharagpur. And then he had a long stint at Asian Paints. Now, in Asian Paints, he basically helped doing projects. And in those projects, he basically was helping them automate, right? So the entire automation journey, he happens to be, at 29, the youngest factory manager of Asian Paints. So that was one of his things. And he did that for close to around 10 odd years before he founded Addverb in 2016, along with other colleagues from Asian Paints. 2021 was I think, watershed moment. That's when Reliance Retail actually invested close to $132 million into their entity. Now he's got other problems to solve. Now he's set up what is called as Botverse, which is a plant manufacturing 100,000 robots annually. Now, that's a different problem statement, and we'll address what could be the challenges which can emerge from that. Now, with that, basically, I would like to, first of all, I mean, before we do anything in terms of each one's companies, what I would like to understand, I mean, let's look at it in terms of, we've got 3 people here, one making for India, one making in India for the globe, and the third one making at scale for the globe, which can also be sold in India. So I would like their perspectives on this factor, saying that what made you choose your particular paths or journeys? I'll start with Twara. So.
Sure. Thank you, everyone. I think shortly, the strong belief in cost of innovation. So I think that's something that's driven me and I think my co-founders, that something that is of a certain value doesn't have to cost so much. But to get into that, you actually need the deep tech. You need to know the material science, the electronics, the mechanical engineering, and all the other disciplines that come into the picture. So it takes a grind, but I think it is possible. And it's just a point to prove and make it happen for the country. That's the intention here. So
Yeah, so we are the team that's building in India for the world with a immediate focus, not so much in India, but for the more developed Western market. And our decision and choice is largely driven by the fact that the technology that we wanted to build is still very new, nascent, so there's a lot of ecosystem that has to come together. And at lower scale, at lower volume, you ideally would want to have a market that can afford higher cost of adoption of the technology. Very Elon Musk, Tesla kind of an approach, right? You start off with your roadsters and then go to Model S and finally come to more consumer goods. So we eventually want to be where Sangeet is, where we are also able to price the product in such a way that it's globally acceptable, but at this point in time, it's convenient for us to build tech and focus on the tech, not worrying so much on the price optimization if you're looking at the markets like US or Germany.
Yeah, when we started in 2016, 100% or for the first 5-6 years, 90% of our revenue came from India. And in these 5-6 years, when our product got stabilized, we said these products are not only for Indian customers, but for customers across the world. And when we had designed this product, we had kept it in mind that we will CE certify it, UL certify it for different markets in Europe and US. So when we got this opportunity to expand outside India, we said we will do it. And today we have 100% subsidiary in US, Europe, Singapore, Australia. 60% of our revenue comes from outside India and 40% from India. We will continue to sell, or 40% of our revenue will always come from India, and that is the onus which we have taken on ourselves. And that would mean educating the customers, which we will continue to do. And we will not restrict. Today we are selling it in 27 countries. We believe that in next 5 years, we can sell to 100 countries, robots made from India to these 100 countries.
So, Sangeet, a follow-up for you is, if you look at 100,000 robots in a year, that comes to around 270 robots a day, right? In 2016, when you started off, you must be thinking about 100 robots a month, right? So what did it take for you to actually transition your thought process from, say, 100 per month to 200 per day or 270 per day? And is the ecosystem available over here? What were the challenges and how did you overcome that?
So when we started thinking of this second factory, we had a factory in Noida. We started thinking of second factory in 2021 when we got this investment. And we saw what was happening in China, we saw what was happening in US. Some of the largest factories there were producing 80,000 robots a year. That is Boston's, Amazon Robotics Boston facility. And the takt time of robot was 7 minutes. We didn't believe it firstly, and then we spoke to several people, and everyone said the same thing. Then we thought, okay, let us see whether on papers is it possible. So, and that was the thought process, and we sat together, all of us, and we started putting it on papers, and at least on papers it was possible. 7 minutes for one type of robot and 15 minutes for another type of robot. At that time we were doing, so one robot used to take 2 to 3 days for us to build. It is electromechanical process and then testing, etc. So on paper, 7 minutes was possible. So we said, okay, we'll put certain lines, 7 of this, and we'll try to build a factory which produces 100,000 robots a year. At that time, we were not even selling 1,000 robots a year. And we said, there is an opportunity in the world. Let us build the capacity, and we will see whether we will be able to sell it or not. We went about and built that capacity. Today, we are at 10,000, 12,000, but I believe that in next 2-3 years, we will be able to use the whole capacity of this factory, because the opportunity is huge in this segment, and we will build another factory.
Nice. Nikhil, in your case, it's slightly different, because you're not really looking at hardware, but you're looking more at software, right? So you're building software and engineering services over here to differentiate yourself globally. Now, from that perspective, what I was surprised to see was when you launched your beehive, your hive in Whitefield. I did not know there was so many robotics ecosystem that existed in India, or at least in Bangalore, especially catering to the software and the software engineering side of it. How do you see that evolving, and how do you see India leveraging the ecosystem around here to maybe encourage other guys to get into that domain?
Yeah, so if you look at the technology stack that we are building, while there is significant hardware and hardware design component to it, the enabling and the differentiating modes that we have built is a lot more soft, and soft could not necessarily mean just software and algorithms. Even your hardware design, there's a lot of soft areas of it, right? So you have the design phase where a lot of it is nowadays digital in nature, where you're going through the mechanical design, the electronics, the product, etc. And there was significant components of what we thought we wanted to build that required product engineering at a very, very deep scale. And so one of the things actually we did very early on, we took a very counterintuitive decision, being a startup in Bangalore, to actually open our engineering center in Whitefield. And Whitefield, at that point in time, at least in 2019, was neither known for, it's not Pina, where you have the hardware manufacturing ecosystem at your next door. Neither was it an Indranagar or a Koramangala or an HSR, where we have the startup ecosystem, right? So Whitefield, in 2022, when we moved to Whitefield was actually almost a ghost town, vacated by TCSs and the engineering centers over here. And now it's, of course, bounced back. We had the good fortune to get good rentals because nobody was occupying these buildings when we moved in. And one of the reasons we did that was we really wanted to be in an ecosystem that had a lot of engineering talent. And that's something that India and Bangalore specifically has been nurturing silently over the last 20-30 years. You have global capability centers of large MNCs hiring engineering talent and grooming engineering talent. You have, if you look at maybe a 5-kilometer vicinity from where we are today, you have GE, you have Airbus, you have Applied Materials. So that was one of the things that we wanted to leverage, which I think globally or across the board, startups could potentially leverage. Our engineering base has been fairly mature over the last 20, 30 years because of the GCC and MNC R&D center establishments around this area. And interesting, there was also a side effect of it. We also managed to kind of, some of the solutions that we deliver requires large-scale digital transformation for these companies in the manufacturing plants of their, in US or Germany. And a lot of the digital engineering and manufacturing engineering teams are also part of these GCCs, right? So we actually right now do business with General Motors, with Applied Materials. We have early conversations with Daimler and Mercedes-Benz. And all of those teams that enable our deployments are also around this geography in this locality and in the city itself. So that's something that has worked really well for us, and it's an engineering strength, a resource capital that we could potentially tap into to build world-class products from India.
Thanks. Kaushik, in your case, your company is differentiating on designing robotic joint actuators and soft grippers. And what I read was 70% of the cost of the robot typically comes in those areas. So how do you see the India ecosystem? How easy or difficult is it for you to get an ecosystem which will help you in achieving your goals?
Absolutely. I think the biggest challenge is precision manufacturing and access to that. And of course, the know-how to make actuators is something that's part of our job. And it is going to be a challenge, but I think it is possible. If we can make cars in India, high quality vehicles and machines, precision machines of many shapes and forms, it is definitely possible to make robots, but it's going to take its own organic time cycle. And I think there is a price elasticity is one term that a lot of business folks use, right? Where currently in India, if you go to an MSME, for them, the robot is a prized possession. It's like this fancy piece of furniture. And everything around the factory is dedicated to the robot's needs. And, but if you think about it, the robot is there to serve the human. The human is not there to serve the robot. And that will only happen if we break that barrier and make it accessible in a way that they own the robot and they develop applications to them. So our main, kind of focus here is to break the value chain and make actuators that can make all kinds of robots in the future.
Cool. Sangeet, one question to you, since you mentioned that you are 60% outside and 40% in here. What are the biggest challenges when you come to Indian companies adopting from a market? There was a session earlier on market adoption of technologies in India. What challenges did you face? The other two are not selling here yet, but since you're doing that, it'll be a good question for you.
Yeah, when we started selling in India, we also did this mistake that your return on investment would come from saving so many number of people. I think that does not work in India, and we also realized it does not work anywhere in the world, though the costs are really high. In Australia, it would be $35 Australian dollar per hour, and in US, it is $18. The ROI in India comes from 2-3 things. One is pace, how you, at least for our technology, how we are able to solve it. The losses, how we are able to reduce it. And many a times it requires the insider in that sector to really note down what are the losses. And sometimes the manufacturer themselves are not able to imagine the kind of losses. The third is the scale. Once there is a scale of operation, you cannot have so many people working together. It will definitely affect the quality, reliability, and accuracy of the product. So once we learned that, and once we started telling it to people, one or two of them understood and they took risk in their industry, and then other people in the industry followed. So that has been our success story as far as India is concerned.
Okay, thanks. Just one last question from me before we go to audience. This is more like a rapid fire. I just want one thing. What are the 3 critical IPs that you guys have developed, right, which creates a moat for you in a Me Too environment? So what are those 3, or may not be 3, you could say, what is that 1 or 2 critical IPs that you feel have been developed by you guys from an India point of view for the global market?
Yeah, so I would say 2-3 things which we have. Our ability to control the whole vertical integration from electronics to sheet metal to assembly to everything. That is one thing which gives us the advantage. The other thing is, in this process, we had control, or we have control of the software at all 3 levels, at the embedded level, at the edge level, whether it is perception, path planning, etc., and at the cloud level, which is MES, WCS, WES, and FMS, etc. So the ability to decide what intelligence will be in what area, and therefore to reduce the cost and give value to the customer, is something which we have done extremely well, is what I think.
Okay. Nikhil?
Yeah, in our case, our core IP and global moat is actually sort of encoded in the name of the company that you were quizzing the audience for. I'm not going to give it out. But the world of robotics, particularly with doing human-like actions, and grasping objects and doing complex tasks, we as human beings often assume that everything is happening in the brain. In fact, it's not everything in the brain. There is a very, very distributed sensory intelligence infrastructure with the eye doing a lot of stuff. The eye is always part of the brain. There's a lot of computation that's happening in the eye. There's a lot of computation that's happening in every joint of your fingers and the arms, etc. So we've the current discourse and the trend is heavily focused on just pushing everything to the brain and magically hoping that the brain's going to solve for everything. We've taken a very foundational, contrarian approach to say it has to be a distributed sensory intelligence. And we've been investing in approaches in each of these aspects of vision and grasping that allows us to do things much better than what the state of the art is able to showcase today in the global platform.
Our 3 biggest IPs would be the advanced understanding of motors and controllers, and our IP in that space. The second would be our gearbox design and manufacturing. Third is actually the application, basically the marriage between these 2, which helps robots take shape, and giving that application-specific firmware or design access to the customer, so that whatever the robot is intended to do in this application is not something that the customer has to invest further funds on. It's something that comes out of the box and just works. So those would be the 3 things.
Okay. Thanks. Now, I just want that quiz question, if anyone knows. What's the full form of CynLr? Go ahead. I think you have it.
Thank you.
But you should not have been answering it. You had
I know.
Time Matrix Forum, so you cannot be answering this. Okay, anyway. So, okay, open to questions. You have 3 veterans over here.
One veteran.
Come on, I don't expect this. I mean, post-lunch session, I hope I've kept you. Okay, one question. Hopefully this will trigger the flood.
So, for aspiring founders, right? So, what's your message if they were to build a robot from India, which is fully functional or on par with Chinese counterparts, right? So, what's your message, or where should they start, right?
Don't start with China.
No.
That's one of the parts I'm saying.
They
Don't be inspired by how China is approaching it. Might not work for us. So that's just one 2 cents from my end. So there's a lot more that we can do, not being distracted by what the benchmarks are being set by the global. I think in our case at least, and I'm not saying this is going to be valid for everybody, my partner Gokul, I'll give a lot of credit for him, has been astutely grounded to what the customer wants. So the problem that the customer wants to solve is paramount, and the design, the tech trend, what you would want to follow is, what you want to adopt is only solving for the customer, not necessarily what the trend is, right? So that's one thing from my end, that as long as we are discovering the customer. So another joke that we internally have, and no offense, Kaushik, is we believe we've done a PhD with our customers because we spent 10 years in the factories before even we started out. And that's really helped us because we've collected all the problem statements from them.
No, I think starting at a customer's place is the best, because no amount of degrees can help you understand, and figuring out the right solution has to be from a customer point of view. And robotics is just the tool to solve the problem. We should not think of robotics as some, end of all. It is at the end of the day solving a problem. The problem matters more than the way we get to it. So if it's a simple solution, we should go for the simple solution. If it's a very complex robotic solution, so it be. So that's the.
I'll also add. See, one is robot, the other is application, and both are challenging. It is not that one is more sexy than another, and finally you will get the money from customer if you solve the problem of the customer, which is application. So there are huge opportunities available today in India. Take one industry which is scaling up really, and try to find the problem there and solve it with a robot, a unique robot which you build grounds up, or an application which uses several robots to solve the problem of that industry. And that is what startups should do initially for the first 3-4 years, so that you start getting the revenue, and then later on you can do whatever you want once you have the money.
Any other question?
This is regarding the autonomous robots. So what kind of challenges you would see, like identifying where to add the intelligence and which device, and whether it should be connected, it should be always operated in a connected mode or disconnected, and how does this play around? I mean, what kind of challenges are you going through while identifying the parts?
Yeah, I assume that it is autonomous mobile robot.
Yeah.
See, there are several challenges. If it is 10 robots working together versus 500 robots working together, and there is a lot of intelligence which is there at the robot as far as safety is concerned, so that it does not harm a human being, or it does not harm a machine, or it does not harm itself, or that intelligence is already built and it is localized at the place. But the information about the tasks, which task to be done first and which robot has to do the task, because that if there are 200 robots working together, what this optimizer or FMS does is it tries to do all the tasks which would be open at that point of time, let us say 1,000, etc., in the minimum amount of time with the minimum amount of energy. And that intelligence lies on the cloud or on-prem server, etc. Hopefully I have answered.
Yeah, thank you.
Yeah, just to add to that, again, robotics is a very broad spectrum, so there are different categories of robotics, and each type of robot you'll have different areas where you might want to improve, right? So in Addverb's case, the majority focuses on mobile robots, so there is navigation and safety around navigation. So we do manipulation, so we do a lot of intelligence on grasping and vision perception, many of which has to be on the edge because there's a lot of heavy real-time decision making. You don't have the time to react if it has to go to the cloud and come back. And I think even at a very low level, component level, at an actuator level, there's a lot of opportunity to kind of bring in that intelligence. It really depends on what product you're building and what you're solving, and depending on what you're building and solving, where you will build that intelligence and what are those roadblocks might vary.
Okay, thank you so much. Yeah, another question I had is regarding the digital twins. Is there a chance that digital twin can help in quicker building of a robot or precision manufacturing of a robot? So is that a technology that can be adopted?
Ma'am, theoretically, yes, but when you get to physics and metallurgy and nonlinear in thermodynamics, there are some terms that cannot be solved. But the way around it is physics-informed AI, which is where something that Sangeet had raised earlier is getting reliable hardware and data from that hardware is one very, very strong way forward. But always reconciling that with physics is the only way we can get a better understanding. Yeah.
Thank you all. I think we are out of time. So thank you for coming here and listening to them. And thank you, panel members, friends, for coming here, spending time to educate or help the rest of the ecosystem learn.
Thank you, sir. Thank you.